So I'm going to be talking about how I would parse this question and present it to students. So what I'm going to do is to look for where the actual question is. Sometimes that's hidden, right? So I've highlighted it there. Reading from the end tends to be good, right? And I'm looking for keywords. So halfway, there's nuclei. There's one nucleus, two protons, one has protons. So I have to maybe unpack what protons are and nuclei for various students if necessary. But then we draw a diagram. Right, this is the mental process of going from a question to a diagram. I'm trying to draw this picture that's described. Marking in these distances. Right, putting numbers that are on the question onto the diagram so they have some meaning. Right, using this word halfway, taking that and turning that into numbers. Right, using this description, we have 2 protons and we have 3 protons, and saying what that means in a more converting those words into a mathematical and physical notation. It's all understanding and comprehending this thing, right? And adding in some other information, like these are electrons, they have these charges. Right, explaining what things are and unpacking terms more for students depending on what they need. Right, and then we talk about what we're actually trying to do here. Right, it's asking you to calculate a force on an electron, right, and that's proportional to the electric field. So we're going to talk about fields. There's a field due to one of the nuclei, and a field due to the other nuclei. We need to draw these in. We've got to start pulling our knowledge into the diagram as well. And then we have to write these things out as ideas, and then there's more terminology here. Principal superposition. So if necessary, I would explain to the students what that is as a reminder or a first off explanation for those who hadn't seen it before. And then we start to break down these terms in this equation. So we've read this equation, we've got to go, well, okay, we've got to work out what E1 is. We have an equation for E1. Right? And then we remember that it was after magnitude, so we start looking at magnitudes. Substitute in some values from our formula, and I would, if necessary, discuss where they came from. Right, we have a similar thing for E2. Right, all the while I'm modelling my thinking, I'm talking to students through my thought process, which is not really a literacy thing, but is part of a problem-solving technique. Right, then again, we're reading this diagram, and I'm realizing that the magnitude of a field will be the magnitude of E1 minus E2, because I've defined which direction is positive, and I know which field is going to be bigger based on which charge is bigger. I start to write the equation out. And again, to assist students in reading equations, I'm going to start by spelling it out and just going one step at a time, because this an equation is like a monologue or a speech, right? A series of equations, right? So you got a point, and if you jump to another point far, far down the argument, it doesn't scan unless someone already knows the argument. Assuming students don't know the argument, you've got to go in steps and go from point to point to point. And that's the scientific literacy. Again, that's understanding how scientists make arguments. Right? We still do that in a mathematical sense as well as in a more logical sense, and we've got to make them consistently. Right, and there's a bunch of technical things like here. I've got a formula for the force. That's where the answer is, but I haven't got a number. Before I do that, there's a bunch of things I could do. Sounds like checking the dimensions. That's what we're going to do next. Right, which is checking that the quantities have the right amounts, and your equal sign means what it means. Right? Reading equal sign, it's a saying that what's on the left and what's on the right are identical, and that means they have the same units. Right, which is what we'll check next. Right, and this process continues. There's a lot of explanation as we go through, and a lot of steps, and a lot of thinking out loud, and a lot of not just writing down equations, but interpreting them and showing students how to read the equations, pronouncing these equations correctly, like the force is minus k e squared on r squared. Some kids will say minus k e2 on r2, and they're going to screw that up if you don't control that. Right? There's a lot of subtle things that, once you think about it, are literacy, but they look like numeracy. Right, okay, I might stop this there. I do go on and finish the equation, but this will take a few more minutes. Right, thank you.